Hi everyone, it's Math with AUB. Some questions for the preparation of a NAT, mostly EK type questions are present. I have undemarcated the line of first year and I have written some questions in mixed type branch, Sunday type branch. Without wasting time, our question number one. Our question number one is the definite integral O to pi upon 4 sine square angle 2x dx. Sine having even power. When sine or cosine having even powers, we always utilize the trigonometric identities. Sine square x is equal to 1 minus cos 2x over 2, while for cos square x we utilize the identity 1 plus cos 2x over 2. When at the outset sine and cosine, either sine or cosine or sine and cosine have even powers, might be power 2, 4, 6, 8, 10 and so on. When sine and cosine have even powers, we utilize these two identities. Sine square x is equal to 1 minus cos 2x over 2 and cos square is equal to 1 plus cos 2x over 2. Before solving these questions, let's see a demo of this one. Even if a mixture of these two present, sine square x times cos square x, both have even powers, we utilize the same identities, sine square goes as is equal to 1 minus cos 2x times divided by 2 times cos square means 1 plus cos 2x over 2 dx. A delicate, a fine situation of a negative ba minus b difference of 2 square situation. 2 to the 4, let me write 4, 1 over 4 outside. 1 minus cos, 1 plus cos, it will become 1 minus cos 2x, 1 minus cos 2x times 1 plus cos 2x dx. Working diligently and proceeding, we have 1 square minus cos square 2x dx. Now we multiply 1 upon 4 and dx, add this integral symbol to each term. 1 upon 4, 1 times dx, negative 1 over 4, we have cos square 2x dx. 1 upon 4, integration of 1 is x. Look here, again we have same situation, cosine having even power, again we utilize the same formula as 1 over 4. It is 1 plus cos, double the angle, cos square x, there is 2x, there is 2x, double the angle, here cos 2x, it turns to be 1 plus cos 4x divided by it. Cos square 2x making the angle double, 1 plus cos 4x over 2. 1 plus cos 4x over 2. Making some space for myself, making some room for the solution of the question. We have 1 over 4 x, it will become 2 for the 8, I am writing outside. Integration of 1 dx and integration of cos 4x dx. We have some situation like this, 1 upon 4x minus 1 over 8, integration of 1 is x, integration of cos is sine 4x, dividing with the derivative of the angle, that's 4 plus c, multiply negative 1 over 8 throughout, 1 over 4x minus 1 over 8x, negative, positive, negative, 8 4 the 32, sine 4x plus c. Taking LCM of this one as 8, it will become 2x minus x minus 1 over 30 sine 4x plus c. It will become x over 8 minus 1 over 30 sine 4x plus c, sine 4x plus c. That is a simple background why to utilize these identities, because these utilize turns even powers to powers of 1 in cosine, and it is really very easy to integrate cosine having power 1. It is really very easy to integrate cos having power 1. Okay, now coming back to our actual question, that we have treaded some path in order to get some idea utilizing the formula. Now we start our major work to solve this question. We have this question. Limits are 0 to pi over 4 sine square 2x dx. Utilizing this identity, keeping this thing in mind that there is x, there is 2x. Double the angle. It question turns to be, if we flip this formula to here, it will become 1 minus cos 4x over 2 dx. Writing 2 outside as 1 over 2, it is in denominator, 1 minus cos 4x times dx. Lingering on the limits of 0 to pi upon 4, 1 over 2. Integration of 1 is x. Integration of cosine cos 4x is sine 4x, dividing with the differentiation of the angle, that's 4 plus c, and putting the limit upper and lower limit. That's the way, that's the style to put limit, upper limit minus lower limit, upper limit minus lower limit, upper limit minus lower limit. Writing this complete function same, first instead of x insert plug in pi over 4, then write same function, instead of x plug in 0, that's putting upper limit minus lower limit and getting some wonderful answer, 1 over 2. X means pi over 4 minus 1 over 4 sine 4 times pi over 4 plus c. That's our upper limit. That's our upper limit. What about lower limit? Minus 1 over 2. Lower limit is 0, x 0. Sine 4 times 0 is also 0 plus c. Pi upon 4, 4 cancel. Sine pi, sine 180 is equal to 0. Sine 0 is 0, that's 0. Nothing is left, only these two terms. 1 upon 2 times pi upon 4. So our answer turns to be pi over. Our answers turn to be pi over 8. That is the limit pi over 4 we have finally, and 1 upon 2 from this formula. 1 upon 2 from this formula. 2 times 4 is 8, pi upon 8 is our right answer in that case. It is the way, it is the path, it is the mode to deal with the integration of sine and cosine having even powers. Sine and cosine having even powers. These are the two magic identities worked wonder for you in trigonometry itself as well as integration, while especially negotiating the integration of sine and cosine having even powers. Moving towards next question.